Generally, we really like Ferris wheel questions because they're sort of in circular motions and kind of, they have maximum points and minimum points and keep revolving. I mean, we also like roller coasters, but it's harder to do kind of work on this with roller coasters than with Ferris wheels. So we've got this Ferris wheel with a diameter of 50 feet, rotates every 30 seconds. The vertical position of a person on the Ferris wheel above and below an imaginary horizontal plane through the center of the wheel can be modeled by this equation. So h of t is the height in terms of time, 25 times sine 12t. We want to find the average rate of change as t goes from 24 to 24.5 seconds. We also want to find the instantaneous rate of change at 24 seconds. It'll basically be the estimate of the instantaneous rate of change. So, how would you find the average rate of change? Katie, thank you. Average rate of change, how do you calculate that? Yes, and how do you calculate slope? Can you look on the first page of your handout? What's the formula for calculating average rate of change? Yeah, and if we were to do it with f of x2 minus f of x1 all over x2 minus x1. So I'll use x2, I'll use 24.5 as x2, x1 will be 24. And so the denominator is 0.5. Substitute 24 and 24.5 into t. So you have to work out the 12 times t first, then take the sine of that, and then after you finish, multiply by 25. Calculate those two values, please. Tiago, please. Thank you. And h of 24. Sure, go ahead.
Negative 23.776.
Great, thank you. And when you do that subtraction, what do you get on the numerator? Christian? And divide that, please. What do you get? Vince, did you get that? The calculation? 1.9? Thank you. And what are the units for that? What are the units there? Kevin Guzzo.
I'm not sure, but feet per second.
Yeah, that's all right. Yeah, because it's a diameter of 50 feet, and it rotates every 30 seconds. So the time, or the distance is in feet, and the time's in seconds. So that's good. Feet per second. Generally speaking, the information will all be given in the question. Okay, so that's great. So that's for the average rate of change from 24 to 24.5 seconds. Okay. Now, if we want to find, now we're not actually finding the instantaneous rate of change. We're finding the estimate of the instantaneous rate of change. So just to keep things a little simpler here, let's do the centered interval for this, just to kind of keep things moving along quickly. Now, in terms of trigonometry, because the values of the angles are fairly large, if you're finding, for example, in this case, it's at 24 seconds, and then we're multiplying that by 12, so that's going to be like more than 240. So because the values are so large, if we're just to add or subtract 0.001, the difference is going to be so tiny, you might actually not be able to tell what the, you won't be able to get a good grasp of the estimate of the instantaneous rate of change. So what I suggest for all questions that have trigonometric functions in them, instead of going to like decimal places to the thousandths of a decimal place like we have in the past, I would just say go to the nearest, say 5 degrees on either side. Okay, now that's degrees, this is seconds. So let's just go to the nearest half second on either side in this case. Generally, if you're trying to plug in some value for this whole angle, so if you were to replace this entire, suppose it wasn't 12t, suppose it were just an angle theta, and you wanted it around some angle of 240 degrees, I would say use 245 and 235 degrees if you're just substituting in for the angle. Because we're subbing in for time and then multiplying by 12, let's just go to the nearest half second as opposed to super precise with 0.001. Okay, so if we do the centered interval technique in this case, then let's do h of, we already have h of 24, so we'll do h of 24, and we've already got 24.5, so that's fine, so let's do 23.5. Okay, so we already have the information from before that we needed. So can somebody please calculate h of 23.5 for me? Okay. 454. Okay, thank you. So then if we do the centered interval, so we'll do the estimate of the instantaneous rate of change. So we're going to go, say, h of 24.5 minus h of 23.5 all over 24.5 minus 23.5. So that works out nicely, which is divided by 1. And 24.5 from what we saw before was negative 22.838. Supplied by Tiago for us. And then we subtract in brackets negative 24.454. So when you subtract there, you got negative 22.838 minus negative 24.454. What do you get for that rate of change, please?
Keaton Gruner to the front office, please. Keaton Gruner to the front office.
What does this numerator simplify to, please? Flynn?
Negative 1.615.
Okay, and obviously divided by 1 is just that. Michael? 1.646.
Yeah, that's
1.646?
1.616.
1.616.
Because when he did, when Tiago did the rounding for negative 22.838, it was actually negative 22.839.
Oh, I see.
So I just,
Okay. Alrighty. So negative 1.615 or negative 1.616.
If we can please ask students to make their way to the football field, into the stadium bleachers.
Should be
Please,
positive.
everyone make your way to the bleachers out of the field. Thank you.
Okay, so the final is actually positive because we got a negative, we're subtracting a negative 24, which is bigger than that.